If this hydrogen here can release itself from the oxygen, then it's an acid. Or let's take this ethanol, and if this hydrogen here also can donate itself away, then now it's an acid too. But how do we know how willing is it to donate hydrogen? In the case of alcohols, primary alcohols are more donating because the oxygen here, due to its electronegativity, it must take care of its hydrogen and its neighbor, the primary carbon. Since the hydrogen's electronegativity is lesser compared to the carbon, it is more likely to leave as a proton. But let's take this tertiary butanol here. The carbon is stabilized by other groups, so the oxygen doesn't need to take care that much about its carbon. So now it's hard to lose its hydrogen. Now what about water? It has two hydrogens to it. So will it be an acid or base? In the case of HCl, if you mix it, it acts as a proton and becomes H2O plus. Now it's a base. But let's also react it with ammonia. Now it donates a proton and becomes OH minus. So we can conclude it's both an acid and or a base. In most cases, it acts as a base, by the way. Now about Cresols, they're just fancy phenols, with the methyl group present. The hydroxyl group makes the phenol want to lose its hydrogen. It is also called as an electron withdrawing group, but the methyl pushes electrons into the chain, which makes the hydroxyl harder to release hydrogen. Now the methyl group has three positions. Let's look at each case. In o-cresol, due to its resonance, the methyl group pushes the electrons to the hydroxyl group, which is a close neighbor, which makes it harder for the oxygen to lose its hydrogen. Now in para-cresol, due to resonance again, it is a bit far, so it has less effect to destabilize the O minus, so it will become less stable conjugate waves, which in turn will make it less acidic. Now in meta-cresol, the resonance doesn't come into play here, only this inductive effect. So the methyl group doesn't play a big part in donating, which makes it more acidic. Now I know most of you would not have understood what I said a few seconds ago. So here's a small explanation. Once the phenol becomes a phenoxide, the electron goes around the ring. This is called resonance, right? Also remember that the phenol's pKa is 10. Okay. Now in the first case of the ortho position, the donating group sits right next to the electron. So the electron gets absorbed and now it's less stable, which means that it's less acidic. Now in the second case, in the para position, the donating group is a bit far, which makes the electron have more time to move around freely roaming, but it will get absorbed eventually. Lastly, in the meta position, the electron never comes to the meta position, so it has no effect on it except some little psi effect. This is why the difference in pK of para and ortho is very little, namely 10.287 and 10.26. Okay, now coming to nitrophenols. Now this is a bit more interesting because everyone here is a withdrawing group, meaning that they all want the electrons, right? So no one is willing out to help out the oxygen. So the more number of groups, the more is the acidity. As we have discussed, the resonance also comes into play here, which is an important thing. Okay. Yeah, so guys, I hope you understood here. I know here's a simple question for you. If you can answer it in the comments. And also put all the reference and the books which I used to research in the description. Yeah, so guys, thanks for watching.